what we're going to be looking at is our focus is parabolas, but we're going to be using what we've already learned last week about conics, or we already reviewed last week about conics. And again, maybe you know some of this, but we're looking at parabolas in their geometric form. So we have a lot of knowledge this year about quadratic relations specific to parabolas, right? Like, well, how do you know if a parabola opens up or opens down? Like, where's the vertex? Like, all of that stuff. So we're going to kind of use that knowledge that we have and use the knowledge that we have about functions and the characteristics of functions, and we're going to apply it to better understand parabolas and given a variety of information, just like we did with ellipses and circles. So a quick reminder, and I said this with the warm-up, but if A equals C and neither one equals 0, that's a circle. If A does not equal C and they're not equal to 0, so they're not, the coefficients of x squared and y squared are not the same, but neither one is 0, but they're the same sign, right? They're either both positive or they're both negative. That's an ellipse. Now, if A or C equals 0, so if you only have one squared term, because one of them is going to be 0, we are going to have a parabola. So in general form, this is what we have. Ax squared, right? So I had it written on the warm-up at the top. So for this, we don't have a C, right? So because C equals to 0. One of them, either A or C, equals to 0. Or we have this, cy squared plus dx plus ey plus f equals 0, right? And A equals 0. So one of them goes away. We either don't have an x squared or we don't have a y squared. We're only going to have one squared term. The first one, where C equals 0, is what you're more familiar with for algebra, right? That's going to indicate the parabola is opening up or down, because that's what you're familiar with. This one, y squared, is there. When you have a y squared, that's not something you're super familiar with. If you think about it, if you take the square root, the inverse function, that's actually not a function, right? So like that's going to be when a parabola opens right and opens left. They can really open any way. We're going to focus on up, down, left, right. Geometric definition. So a parabola is defined as the set of all points in a plane that are the same distance, or maybe you remember that word, equidistant, from a fixed point called the focus, and from a fixed line called the directrix. We're going to look at this visually. Maybe. Yes. Okay, so that point right there, that's my focal point. That's my focus. That line right there, that's my directrix. This point halfway between them, that's a point that is equidistant from my fixed point and my fixed line. So from my focus and my directrix, that point, that shortest distance, that my most direct path, is my vertex. These two distances we're going to refer to as P, and they're the same. Oh, where'd my vertex go? I'll re-put it there. There's my vertex. Right? So there, this point up here is another point on the parabola. That's another point on the parabola, right? That's going to be equidistant if I were to connect it from the focus and the directrix. Focus, the directrix. It's the most straight path. Like it's the perpendicular path to the directrix. I can also have it, and let's take a look over here. There's my focus. There's my directrix. That's my vertex. That distance is P, right? The difference here is that my parabola is going to open to the right. It's never going to go through that directrix, right? This point right here, also equidistant from the focus and the perpendicular distance, if I dropped a perpendicular to the directrix. That point as well, right? So if we look over here again, that distance to the focus point, that distance to the directrix are the same. Okay, P is just that shortest distance. So if you take a look up here, this is pretty interesting. How a parabola is formed. Is it going to do it? No. Come on. Where'd it go? Oh, they're here. Well, my drawings went away now, right? So you can see that that distance is always the same, no matter where you are. So you have focus, directrix, that's your vertex or your midpoint of those. That distance is the same, that's P. And then as we move it, that distance, that red and that blue line, or whatever colors those are always the same. Okay, so standard or graphing form. If it opens up, this is what we're looking at. Right, so x minus h squared equals 4p y minus k. Right, so that the p, that shortest distance, is in there. H and k are your vertex. So what's going to happen if we want it to open down? Oh, that 4 is going to become negative. Right, so that's the piece that's different here. My x is still my squared term. P, that shortest distance, is still a part of it. If it's opening right, look what happens here. Oh, it's your y squared. That's your y term that's squared. Right, so you just need to be mindful that k is going with y. So don't always just look at it left to right. Look at where is h, like where's your x term, where's your y term. So if it's opening to the right, your 4 is positive, but it's your y term that's squared. So for up and down, x term is squared. What's going to happen to make it open left? Oh, this is going to be negative. The 4 is going to be negative, right? So if it's your right and left, it's your y term. That's the one that's unfamiliar to you. Like we have it in algebra. Yeah, as a function with y as squared, that's not a function. So I think, oh, sorry, I kind of wrote over that. My bad. You're used to seeing that dilation factor, right? That a in front of your squared term, right? Like when you expand it, this is obviously a little bit different. But just keep in mind that we can go between the two. Like this is the geometric definition. The algebra form that you're used to is just a manipulation of this. That's all that's happening. Like we can switch between them. So you might see it in y equals ax squared plus bx plus c, and we ask you to put it in this standard or graphing form. So this is just the geometric definition. Let's take a look at one that we're going to graph. So you have y minus 2 squared equals 8 times x plus 1. So we want to label the vertex, directrix, axis of symmetry, focal points, x and y intercepts. So let's take a look at this. Well, which term is squared? Well, our y term, right? So it's either going to be right or left, right? If your y term is squared, we know that it's right or left. Our vertex, I need a pen. I'm going to graph this as we go, is negative 1, 2. So there's my vertex. I'll label it negative 1, 2. Oh, sorry. 8, well, that's 4p equals 8. Well, since 4p is positive, we now know that it's going to be opening to the right, right? So to get from my vertex to my focus, I'm going to have to go to the right. The focus is going to be inside the parabola. So p is 2, so that means I'm going to go 2 to the right, 2 to the left to get to it. Can I erase my pen? I think I can. I'm not sure how though. There we go. I'm gonna label this a little different because this is I forgot that I already put this in. So this is negative 1, 2. This is my focus, and I went 2 to the right, so this distance is 2, and this distance is 2. If I go 2 to the right, this point right here would be 1, 2, and 2 to the left, I'm going to have the equation of my directrix will be x equals negative 3. Oh, sorry. Oh, darn. One more time. Negative 1, 2. This was 1, 2, and this was x equals negative 3. So we have to find, so we've done the vertex, we've done the directrix, we've done the focus, right? So I need to find some more points on this parabola. So there's a variety of things that I could do right now. Well, I know any point on it is going to be equidistant from the focus and from the directrix. So I can kind of create a box, and this will always work if you ever need more points. So this distance is 2 and this distance is 2. So to get from my focus to my directrix right now, I am going to go 4. So this like horizontal distance here is 4. So that means anywhere I move out here, I want my distance to be 4. Well, if I go 4 up from 1, from 2, right? So this is like 1, 2, 3, 4, 5, 6. So I'm going to go 4 up. Well, this point right here, the point 1, 6, is 4 away from the focus and 4 away from the directrix, right? I can do the same thing and go 4 down. Well, this is going to be 2, 3, 4. This point right here is going to be about 1, not about, 1, -2. This point, 4 away from the focus, 4 away from the directrix, right? -3 to 1. So I can now, and I'm going to graph it as best I possibly can. And then we'll talk about the x and y intercepts. So for the x and y intercepts, this is where I want you to go back to what you already know about functions. To find an x-intercept, what do we know at that point? Like anything on the x-axis, your y value is equal to 0. So x-intercept is where y is equal to 0. So I'm going to plug in 0 for y. So here I'm going to have 4, right? -2 squared equals 8 times x plus 1. I'll divide by 8, so 1/2 equals x plus 1. Subtract 1, and I'm going to get x is -1/2. So this point right here, my x-intercept will be -1/2, 0. How many y-intercepts do we have? Oh, 2. Oh, wait, 2. How do we find those? Find the y-intercept. Your x value has to be equal to 0, right? Anywhere on the y-axis, your x value is 0. So you've got y minus 2 squared equals 8 times 1, right? Just that. So when I do the square root of that, y minus 2 equals plus or minus 8 is 4 times 2. So that's 2 root 2. So y is going to equal 2 plus or minus 2 root 2. 2 root 2 is approximately, it's somewhere between 2 and 3. So I'm going to be going 2 plus like 2.8. So I'll say y is about 4.82 and about, what is 2 minus 2? Just for graphing purposes, -0.82, so on. It keeps going. So just to get that. So 1, 2, 3, 4 point. Oh, this is not a very good one, but that's okay. So that point is going to be about 0, 2 plus 2 root 2. And this point is going to be, I'm very off, obviously, 0, 2 minus 2 root 2. So where am I at now? I got the x and y intercepts. So my last thing that I'm missing is the axis of symmetry. So that's like the line of symmetry. It's going to divide this in half. So that's going to go through the vertex and through the focus. So right here is my axis of symmetry. And what's the equation of that? Well, it's a horizontal line. So it's going to be y equals 2. Fantastic. Okay. Let's look at another one. If you think you've got it and you want to pause the video and try this, I think that's a fabulous idea. If not, it's okay. I'm going to go through it. So I have x squared. My squared term is my x term. This is ridiculous. Sorry, it's a double negative. Ignore one of them. So I know that it's going to either open up or down? Right? If I focus in on this right here, it's negative, so therefore it's actually going to open down. And I think that's an important thing to go into it knowing. So where is my vertex? My vertex, HK, is negative 6, 2. 1, 2, 3, 4, 5, 6. And I know the scale is hard, I'm sorry. So negative 4p equals negative 16, right? Therefore, p is going to equal to 4. So we said it was opening 4 down. So I need to go down 4 to get to the focus, right? 1, 2, 3, 4. So that point right there, what is that? 6, negative 2 is my focus. I need to go 4 up, right? So focus, here I'll write it over here, is 6, negative 2. I'm going to go 4 up to get to my directrix. 1, 2, 3, 4. Y equals, what was that? 1, 2, 3, 4, 5, 6. What was this point? Negative 6, 2? Yeah. The directrix, it's an equation, is y equals 6. So I'm going to find 2 more points. I'm going to go back to the red just so that I know what I'm actually connecting. So the distance, this distance is 4, this distance is 4. So if I go 8 to the right, 8 to the left, that's going to give me 2 more points from the focus. So I'm going 6, 7, 8. There's a point on my parabola. 1, 2, 3, 4, 5, 6, 7, 8. There's a point on my parabola. So I'm just going to like roughly sketch this. Oh, I missed. This is going to be like a wide parabola. I'll do the axis of symmetry, and then we'll do x and y intercepts. So the axis of symmetry is going to be x equals negative 6. Oh, I forgot that should be a negative 6. My fault, the focus is negative 6. Okay, so axis of symmetry is x equals negative 6. Yeah, so my last thing that I want to find, and I'm going to do it algebraically, obviously, is the x and y intercepts. I'm going to do them up here. So the x-intercept, how many do we have? It looks like we've got 2. So that's going to be where y is 0. So x plus 6 squared equals negative 16 times negative 2, right? So x plus 6 squared equals, what is that, 32? When I do the square root, x plus 6 equals, well, that's 16 times 2. So that's going to be plus or minus 4 root 2. Minus 6, so x equals negative 6 plus or minus 4 root 2. So I don't know exactly what that is. I'm just going to hope that I'm somewhat close. So this point right here is going to be negative 6 minus 4 root 2. Right, that makes sense. I'm going 4 root 2 from that vertex to the left. And then this point over here is going to be 6 plus 4 root 2, comma 0, negative 6. Let's see what that is approximately. What is negative 6 plus 4 root 2? Well, I'm a little off, but it's not bad. Okay, so then the y-intercept. The y-intercept is going to be where x is equal to 0. So if I plug in 0 for x, I'm going to have 6 squared, which is 36, equals negative 16 times y minus 2. I'll divide both sides by negative 16. 36 divided by negative 16 is going to give me a decimal, but I'll go with I'll do the decimal, negative 2.25. equals y minus 2. If I add 2, I get negative 0.25 equals y. Oop, my pen's dragging. So that means this point right here is about 0, negative 0.25. I mean, that should be the approximate, but that means that that's about that. Fantastic. You won't always have x and y intercepts. Keep that in mind. You won't always have like all of it, and you'll see what happens when that's true, right? Like if my vertex was below and it opened down, I wouldn't have x intercepts. Awesome. Okay, let's do one more. So this is going to open right or left because it's my x, my y that's squared. Because of this 4, because 4p is positive, it's going to open to the right. So whenever I figure out what the vertex is, I know that to get to the focus, I'm going to have to move to the right. So the vertex, hk, is negative 3, 2. The focus, so I have 4p equals 4, therefore p equals 1. So I'm going to have to go 1 to the right. So I'm going to end up at negative 2, 2 for the focus. For the directrix, I'm going to have to go left 1. Oh, I just missed that. So that's going to be x equals negative 4. So if I want to find 2 more points, I'm going to go from the from the focus to the directrix, that's 2. So I'm going to go down 2, and I'm going to go up 2, and then I'm going to sketch my parabola. That one was a little bit easier for me. Oh, no, it wasn't. I talked too soon. Okay, so axis of symmetry. That looks like it's y equals 2. I missed it a little bit, but axis of symmetry. Okay, so my last thing are x and y intercepts. So x-intercept, I'm going to plug in 0 for y. So that's going to give me, if I plug in a 0 for y, negative 2 squared is 4 equals 4 times x plus 3. I actually know it, don't I? Because I found it right here. So when I divide by 4, I get 1 equals x plus 3. Subtract 3, negative 2 equals x. I have that, right? Negative 2, 0. For the y-intercepts, I'm going to plug in 0 for x. So I'm going to have y minus 2 squared, and I can see that there's going to be 2 of them, equals 12, right? Because when I plug in that 0, I get 0 plus 3 is 3, times 4 is 12. When I take the square root, y minus 2, well, what's the square root of 12? Plus or minus 2 root 3, because that's 4 times 3. So I get y equals 2 plus or minus 2 root 3. So this point right here is going to be 0, 2 plus 2 root 3. This point right here is going to be 0, 2 minus 2 root 3. And that is our parabola when we're given it in graphing form with the geometric definition. Okay, what about transforming? What if we're not given it in graphing form? So something like this. We've got x plus 5y squared minus 30y minus 11 equals 0. Like, does this open right? Does this open left? Does this open up? Does this open down? Like, how do we know? Well, what term do you have that's squared? Right? So it's my y term that's squared, so I know that it's either right or it's left. What is the vertex? What's P? Can we tell it from this form? No, sorry. So what we need to then do is I need to do some completing the square. So let's do some rearranging. So think we know we want it to look like this at the end. Y minus k squared equals 4p times x minus h. Right? That's what we know we want it to look like at the end of this. So let's get this organized. 5y squared minus 30y equals, let's move this and this to the other side, equals negative x plus 11. So in order to do completing the square, I need this 5 gone. But just like when we were working with ellipses, I can't just divide by it. That's not going to really do anything for me. So let's go ahead and factor it out. I mean, I guess I could. I'm just going to avoid that. Y squared minus, so I'm going to divide by 5 and divide by 5, minus 6y plus something equals negative x plus 11 plus something. So let's see. I still have that 5. What do I want this to be? Well, y, those two numbers are 3 and negative 3, meaning this would have been a 9. But what would I have really added up here? Right? I divided it by 5. So, well, I already divided something by 5 to get that 9, so I've got to factor that back in. So it's really a 45. I'm really adding a 45 here. Right? So I really have negative x, 11 plus 45 is 56. So I'm close, but I'm not quite here, right? Like my coefficient is not in front of the, what's it called? It's not, I don't want it in front of the squared term. So what I want to do, and I also have this negative here that's stopping me, so why don't we go ahead and factor out that negative? So I'm going to factor out a negative 1, and then it's going to be x minus 56, and then I'm going to go ahead and I'm actually going to divide by 5. So I now have y minus 3 squared equals negative 1/5 x minus 56. And that is graphing form. So from this, I could then tell that, oh, my vertex is going to be 3. No, it's not. 56, 3. I can tell that this is going to open to the left. Right? This is negative. So I would say negative 4p equals to 1/5. So you would have, I'm sorry, negative 1/5. So you would have p, that distance, is actually going to be 1/20. It's going to be really narrow. Right? So we want this in graphing form or standard form from general form. We're going to do more with this. So we're going to practice. I think I have like 5 or 6 problems that we're going to practice with, and I think these are great problems to kind of check your own understanding at this point. So maybe when I get to each problem, pause it, try it, and see where do you get stuck so that you know what you need to work on. So this first one, we're going to do the same thing we just did. Complete the square. You might actually know this one's going to open down. Right? That's something you're familiar with. So I know at the end of this, I want it to look like this. X minus h squared equals negative 4p y minus k. So let's get some rearranging done. I'm going to get all my x's on the left. X squared minus 2x equals, let's get that on the right, negative y plus 4. And let's do some completing the square. What's going to go in these blanks? Well, I don't need to factor anything out here, right? So this is just going to be x, those two numbers that add to negative 2 that are the same, negative 1 and negative 1. So that means I'm going to be adding a 1 equals negative y plus 5. So I'm close, but I need to know what is the coefficient, x minus 1 squared. I've got to factor this number out, that negative 1, y minus 5. And just like that, it's in graphing form. The vertex is going to be 1, 5. The focus, let's see, negative 4p equals negative 1, so p equals 4. We said it's going to open down, so I'm going to be going down 4 from the vertex. So that's going to be 1, 1, right? That affects y. To get to the directrix, I'm going to have to go up 4, right? If it's opening down, that means that my directrix is going to be horizontal. So it's going to be y equals, if I go up 4, 9, right? So I add 4 to my y value. I subtracted 4, and then I added 4. Yeah, that was what it was looking for, right? I guess if it wanted the axis of symmetry, and if you want to practice graphing this, I think that's a great idea. If you want to practice finding x and y intercepts, I think it's a great idea for this. The axis of symmetry is going to be x equals 1. It's actually what these two have in common. Another completing the square. Try it on your own. Oh no. This needs to be a y, I'm sorry. Alrighty, so this is gonna open either up or down, right? I believe this is gonna open down. So I want it at the end to look like x minus h squared equals negative 4p y minus k. So let's do this. No, this has to be an x. Oh, I was fine. It wasn't a typo. I didn't see this y over here. Okay, so we're going to do some rearranging. So negative 2x squared minus 12x equals negative y plus 17. I guess I could have rearranged that better to not have any negatives. Would you guys have liked that? It's okay. I'm going to factor out, right? So I know I have to complete the square. I'm going to factor out that negative 2 in order to do it. So negative 2 x squared plus 6x plus something. And then I still have that negative y plus 17 plus something. So those two numbers that add to 6 are 3 and 3. So this would have been a 9, but I had factored out a 2, right? Like I divided all of these by 2. So this is really an 18. So I'm really adding 18 over here. No, I'm not. I'm really I subdivided by a negative 2. I'm really adding a negative 18. So this is going to equal to negative y minus 1. So just like we did before, I'm going to factor out that negative 1, and I've now got y plus 1. And then I don't want this coefficient here, so I'm going to go ahead and divide by negative 2. Look, I was wrong. So I'm going to have 1/2 y plus 1. So this didn't open down, this opened up. It's okay. So the vertex of this is going to be negative 3, negative 1. The focus, I know I'm going to be going up to get to the focus and down to get to the directrix. So I have 4p equals 1/2. So p is going to equal, if I divide by 4, 1/8, right? 1/2 divided by 4. It's like you're splitting up a half into 4 parts. They're each going to be an eighth, right? Or it's like you're multiplying by 1/4. Dividing by 4 is like multiplying by 1/4. So I'm going to be going down. So that's going to affect y. So negative 3 and then negative 1 minus 1/8 is negative 9/8. And then I'm going to be going up to get to the directrix. No, I just did that wrong. Didn't I flip that? I'm going to be going up to get to the focus. Sorry. Down to get to the directrix. So up to get to the focus, so I have -1 plus 1/8, which is going to be -7/8. My fault, guys. And then I'm going to be going down to get to the directrix. So it's going to be a horizontal line, so it's going to be y equals, right? It's only affecting y. And that would be the -9/8, wouldn't it? -1 minus 1/8 is going to be -9/8. Okay, so a few different types of problems now. So given a parabola with a vertex at 2, 3 and a focus at 0, 3, write the equation of the parabola in standard form, then graph and identify the characteristics. So think about this. You have 2, 3, and you have 0, 3. So they're at the same height. My x value is what's changing, right? And so I'm actually going to the left. If I had the point 2, 3, let's say I plotted a point, and then I have the point 0, 3, I'm going to the left to get from the vertex to the focus. So I know that this is going to open left, right? So what does that change? How do you go and focus in on the 0 and the 2? That distance is 2. That's your p-value then, right? I know I have a graph down here. I'll graph it after. So I know it's going to open left, so it's going to be a y squared term. So I have y minus 3 squared equals 4p, or -4p, x minus 2. Right? So y minus 3 squared equals -8, x minus 2. And that is standard form. Well, if I went left 2 to get to the focus, I have to go right 2 to get to the directrix. So that's going to be x equals 4. Right? I added 2 to my x value. The axis of symmetry, well, that's going to be y equals 3. Right? That's when if I were to draw a line through the vertex and the focus, well, that line is going to be at y equals 3. How do you find the x-intercepts? Well, I'm going to plug in 0, and I'm literally going to graph it last. I'm going to plug in 0 for y. So that's going to give me 9 equals -8, x minus 2. If I divide 9 divided by -8, and then I add 2, I get 7/8. So it's the point 7/8, 0. What about the y-intercept? I'm going to plug in 0 for x. So plug in 0 for x. Well, I'm going to get y minus 3 squared. So I'm going to have 2 solutions. Equals 2. If I plug in 0, I get -2 here. So 16. Oh, this is a nice one. Square root y minus 3 equals plus and minus 4. And then you add 3 to that. So y is going to equal to 4 plus 3 is 7. -4 plus 3 is -1. So I'm going to have the point 0, 7 and 0, -1. So now we've got everything. Let's graph it. 2, 1, 2, 3. My focus is 0, 3. My directrix is x equals 4. The intercepts, let's go ahead and do those because those are nice, I think. Kind of. I mean, 7/8 is going to be like right there. That's my x-intercept. My y-intercept is 0, 7. So 3, 4, 5, 6, 7. And then -1. Notice those y-intercepts helped me because they were on the same line. Like when 4 away, oh, I went 4 up and 4 down. to get to them. So I didn't need those other 2 points. I should label these 0, 7, 0, -1, and then -7/8. No, that's +7/8. 0, sorry. The last thing that I need is that axis of symmetry I should graph in is y equals 3. So I gave some different information here. I didn't just give you the formula this time. Let's do another one similar to that. Given a parabola with a vertex at 4, 1, and a directrix at y equals 5. So 4, 1, and the directrix is y equals 5. So that's going to be clearly above this, and y equals 5 is going to be a horizontal line. So this is going to have to open down. Right? Because I went to get from my vertex to my directrix, I went up. And this can't open left, it can't open right, it can't open up or down. Like it has to open down because it can't cross the directrix. It's not touching that directrix. So to get, what is this gap between the directrix that's at 5 and this point that's at 4, 1? Well, we're going to focus in on the y value, right? Because that's the up and down piece of it. So how do you get from 1 to 5? Oh, that gap is 4. So that means I'm going to have to go 4 down to get to the focus. Right, so I know that I'm going to have, it's opening down, so it's going to be x minus 4 squared equals -4. Well, that p-value is going to be 4, y minus 1. X minus 4 squared equals -16. Y minus 1 is going to be the equation in standard form. We just said we were going to have to go down 4 from the vertex, so my x will stay the same. Down 4 from the vertex is going to be, what is that? 4, -3. 1 minus 4 is, yeah. Okay, so that'll be my focus. The axis of symmetry, well, it's going to be a vertical line that crosses, so it's going to be a x equals, well, what does x equal when it crosses the vertex and the focus? X is going to equal to 4. The x-intercept is where y equals 0, so let's go ahead and do that. X minus 4 squared equals to 16, right? -16 times -1. Perfect. When we do the square root, we get x minus 4 equals plus or minus 4. So your x-intercepts will be, if you have -4 plus 4, that's 0. If you have +4 plus 4, that's 8. So you're going to have 0, 0, and 8, 0. What about the y-intercept? That's where x equals to 0. So you're going to have 16, right? 0 minus 4 squared. 0 minus 4 is -4. Square root of 16 equals -16, y minus 1. We probably know what it is because we have a point of 0, 0. Divide by -16, you get -1 equals y minus 1. When you add 1, you get 0. So you have a point there again at 0, 0. So let's now graph this. So the vertex is at 1, 2, 3, 4, 1. And the directrix is at y equals 5. 1, 2, 3, 4, 5. The focus, we went down 4 right there about, and that was 4, -3. I know the axis of symmetry is x equals 4, and now you can kind of see it all come together. And if you needed the graph, that's fine. 0, 0, and 8, 0. 2, 3, 4, 5, 6, 7, 8. And I could totally graph this right now. Let's say I wanted some more points. The distance from here to here is 8. I could go 8 to the left and 8 to the right if I really wanted. I'm not going to right now. Because having that x and y, I think that's useful when we don't have an x or y intercept, or like they're not plottable. So what was this? 8, 0, and 0, 0. My graph is pretty terrible going on there. It should be wider, but that's okay. And then my axis of symmetry is at x equals 4. All right. Okay. So we're going to close out with this last one where I'm actually going to give you the graph and then ask for the information about it, okay? So it's opening to the left, and I think it's important to note that, and I probably should have just asked for the standard form last, this vertex is at positive 3, negative 1. Since it's opening to the left, our y term is going to be squared. So y plus 1 squared equals 4, negative 4, right? Well, what's p? Well, the focus is at 0, negative 1. So 0, negative 1 means you're going left 1, 2, 3. So your p is 3, x minus 3. So my standard form would be y plus 1 squared equals negative 12, x minus 3. The directrix is at x equals, what is this, 6? Yep, 3 to the right. The axis of symmetry is going to go through the vertex and the focus. That's going to be at y equals negative 1. Check that out. Like if you look at these, well, what do they have in common? The x-intercept is where y equals 0. So that's going to give us 1 equals negative 12 times x minus 3. Divide by, so you got negative 1/12 equals x minus 3, and then you add 3 to that. So what's negative 1/12 plus 3? It's like really close to 3, so 35/12. Oops. I guess that's right. It's like really close to 3 right there. 35/12. If it was 36/12, it would be 3. And the y-intercepts we can see, but why don't we do it algebraically as well? So that's where x equals to 0. So y plus 1 squared equals, that's going to be 36, right? When we take the square root, y plus 1 equals plus or minus 6. So y is going to equal to 6 minus 1 is 5, and negative 6 minus 1 is negative 7, right? Which we can see here. And then you can also see with those points, well, the distance, this distance right here is 2p, right? 1, 2, 3, 4, 5, 6. And this distance is also 2p, right? So if you just go from the focus out, they have to be the y-intercepts for this one, but that would work as well. Awesome. So we did a lot in this lesson, right? So we used what we knew about functions, right? And finding like x and y-intercepts here. We used what we knew about quadratic relations, like how do you know if it's opening up or down? Like how do you know if it's opening left or right at this point, right? It wasn't unfamiliar to us. To look at it in a variety of forms. So whether I gave you an equation, I gave you 2 pieces of information, I gave you a graph, or I gave it to you not in graphing form, and you had to do some completing the square like we did with the other conics, to work with and interpret a parabola and analyze it. So I encourage you guys to do some of the practice with this. I think this is a little bit different than some of the stuff that we did last week. So please practice it with any of the Khan Academy assignments, the worksheets, or even the quizzes. And when you are ready, go ahead and do the next lesson, which is on hyperbolas. Thanks for watching.